Okay, so firstly, let's see this one. Rational expression. Rational expression equation actually it means if you have A over B equals C over D, if the left side only is rational expression, right side is rational expression. This is called ratio, right? Ratio, or we also proportion part, right? In this kinds of equation, we can say both side time BD, right? BD definitely cannot equal 0, right? So like this one is B was over, D was gone. So you can got AD over BC, right? Just like a crossing. So after that, transfer the rational expression into this kinds of equation without a rational expression. So you can find the solutions with what we learned earlier methods. Yes, this one maybe transfer polynomial kinds of multi-terms and right side multi-terms. You can use like what we learned earlier, just like factor methods or zero theorem methods to find the solutions. So this is basic kinds of situation. Second, the rational expression, if they have two parts, A over B plus C over D equal E over F, right? There's a multi-rational expression. So you have to transfer this one to rational expression, right? Like BD, you have AD plus CB equal E over F. So right now you can transfer left side is one rational expression, right side is one rational expression. And you can use the crossing methods to get the equations like this one, right? Okay, so let's multi several ways. Actually, just try to get rid of the rational expression and transfer to the general equation and find a solution out of there. So let's go back to see the homework part, right? So see this one, the rational expression. They have multi rational expression here. So first we just try to get rid of them, right? Or we can just combine left part and right part, and then we use just like AD over BC kinds of methods. Let's see this one. So right, these equation is right here, right? So left have two rational expressions, right have two rational expressions. Let's combine left part first, right? So left part, they have the same denominator, right? So we can use here got a 2k plus 3, right? The top part plus together. So equal 4k, k plus 4, right? So right now, to make it easier, we can just get rid of both sides times 4, right? We can get this 4 off away. So next step, we use the cross methods. Right? All right. So you get k times 2k plus 3 equal k plus 4. So right now it's transferred into general equations, right? So you can get 2k squared plus 3k left, right part is k plus 4. And all move to the left, 2k squared plus 2k minus 4 equals 0. So we take 2 away, all right? So like 2 to 2, we can take it both sides, divide 2. So you can k squared plus k minus 2 equals 0, right? So we can use the factor methods. X plus 2, k minus 1 equals 0, right? Right? So you can get a k equal -2, k equal positive 1. So you have two results, two solutions, right? So methods, you can see quickly. First, we combine. Second one, we use the ABCD methods. We distribute inside and combine to one side, and then make it a simplifier and use the factor methods and use the zeroing methods. You got solutions, right? Okay, let's see second one. Second one. So right now, first, we can use the you can also use the same find their least common denominator methods. Okay, like this is 2m squared m2. So 2m squared is their least common denominator, right? So means we can both sides times the same, both sides times the least common denominator. All right. So left part is got 1. The right part we distribute inside. All right. So became 2m squared over m, right? 2m squared minus 2. All right. So you can got here is 2m, right? We cross this out. What about this part? Right. So move all to left side. M squared minus 2m plus 1 equals 0. So what do we get? M minus 1 squared equals 0. So m equal 1, right? Actually have two answers. M1 equal 1, M2 also equal 1. So you get it quickly out of there, right? Anyone have any questions? Or your answer is same to mine? Anyone clear what are we doing, try to do here?
Yeah.
Yeah.
Okay. All right. So let's move number 3. Number 3. This is also rational expression have multi, 1 rational expression, 2 rational expression, a 3rd rational expression. So we find the LCD first. So you can see we can quickly find LCD is 2n squared, right? So both sides times the same 2n squared, right? Both sides times 2n squared, right? Both sides times the same number. So first in this part, in that part, we can just get a little bit here, right? So 2n squared minus n minus 6. What about here? 2n squared here after get rid of this n, so left is 2n, right? And what about right side? Right side only n left, right? A little bit complicated, but we know the theory behind. We know the logical progress behind, right? So let's simplify it. Let's first we distribute it inside. This one became 4n squared minus 24n, and right side n squared minus 6n. So we like combine like terms. So here became negative 2 and negative 3n, right? Square. And we see this part, then negative 26, so became negative 20n, right? And last one, minus 12. All right, we make it more simplified. Can we make simplified? We can both, since they are both negative, we can both sides become all positive, right? Both sides times negative 1. All right, so we can use the methods. How we do that? How we do this one, right? Did you guys factor this out? 3n with here, because so here is a times c, 36, right? 36 times, we can time what? Because the two of the factors, sum of the two factors is 20. So we can time 1 times 36, 2 times 18, right? Got 20. So here means breaking down 2n plus 18n. Right? So easy for us, right? So you can go 3n plus 2. What's the next? n plus 6. Right? So you can 3n, 18n, 2n, 18, 20. Here got 12 equals 0. All right? So what do you got? So n1 is negative 2 over 3. N2 is negative 6. So you can see the progress actually is so clear here. First, we get rid of the rational expression. Second, simplify. The third, combine like term. And then we factor them, right? And use the zero theorem, we got the solutions. So the progress is right here. Okay, let's see the number 4. Number 4. So here is give a very quick, actually is 2x squared is their least common denominator, right? So all both sides times 2x squared, right? Left, right. Okay, so what do we need to do? We just distribute inside. Distribute inside first. Here you got a 6x squared plus 48x plus 96. What about right part? Right part, I'm sorry, left part, the second part here. We got at least 2, right? First with 2 distribute, second one is only left here. Right one, 2x squared, so equal 2, right? So combine like terms. So 6x squared plus 49x, here is 90. 90 minus became 88. Right? Okay. So this one a little bit complicated, right? A little big number, 2 big numbers. So you guys needed to pay some time to how to factoring. So 6 times 88. How you got to find this 2 sum of them equal 49. So actually we maybe needed to do a little bit more here. Like I say 12 times 44. No, too big a number, right? So you can got maybe say 8. So 11 times 8 times 6. Oh, still big numbers. So needed some, you guys, I will let you guys do these kinds of the rest. Take a little bit longer time to factor. Factor is big number factor progress, take a little bit longer. All right, so I'm leaving here to you guys. Take it to a little bit longer time. We try to find out what is best fit here. Okay, all right, let's move on. Number 5. What do you guys answer? What you guys answer? Did you guys have answer here? Can you guys put your answer here? Definitely have, maybe have 2 answers, maybe have, sometimes have no answers. If they are cannot factor properly, maybe don't have get answers. All right, let's move to number 5. Number 5. So here, actually, right part is easy, right? Right part is easy. You can combine right part first. Actually, it became 3k squared. So you can got it here, right? Right part, we can do this quickly combine together first. And then we do the A, B, C, D progress. Or we can get rid of this 3k or both sides times 3k cubic, 3k cubic at the same time. So right left here is gone, the right part here is left 1k. So we can make it way much easier. So became k squared plus 2k minus 8 is left part. And right part here is k, so get a 4k. Right? So k squared minus 2k minus 8 equals 0. Okay, minus 4k plus 2 got 0. So you got a k1 is 4, k2 is negative 2. Right? Way much easier. Okay. Let's go next one. Number 6. Number 6. We combine left. We find the least common denominator actually is 3k, right? So both sides times 3k. All right. So you can left here is k squared minus 1 equals 3, right? Okay, so you can get k squared equal 4. K equal plus minus 2, the 2 of them. Okay. Did your answer is the same to mine?
Yeah.
Yeah.
All right. All right, let's move on down. Move more. All right, see number 7. That's the easy one right here, right? Okay, so left actually here we can combine first. Combine first, right? So it became 6x. We can link them together, right? So 6 factor out and move the x to the right here, right? So let's see the next. So left part is x squared minus 2x. We combine these two, right? And minus 14. And right part is x squared minus x. X is gone. So we can got the negative x equal 14. X equal negative 14. Oh, that's the easy one. All right. See the number 8. Number 8, we combine right part first. Here became x over x, right? So actually equal 1, right? The right part, x over x equal 1. So it means x squared equal 1. So x equal plus minus 1. Oh, that's much easier, right? All right, let's go number 9. It's number 9. Number 9 right now, yes, became a little bit confusing right now. Not confusing. Let's see the right part first. Right part we combine them. So r plus 10, right? So we can use the crossing methods. Crossing methods, r minus 2 equal r plus 3 times r plus 10. So right part here actually r squared plus 13r plus 30. Right? All move to the right. R squared plus 12r plus 32. So right part actually quickly can factor in is 48, right? So R1 equal negative 4, R2 equal negative 8. Double check here. Double check here. Make sure R cannot equal negative 3, right? R cannot equal negative 3, R cannot equal 2. If they are in this list, we need to get rid of them. Okay. All right, see number 10. Number 10. Number 10 here, be careful about this one. Something like you made this kind of situation, you cannot use the whole piece as the just like when you try to find LCD here, like this one, this one can be further factored, right? We can quickly see this one can be further factored. You cannot use this polynomial time here. Because of this part, it can be further factored. So we do some basic simplify in first step. So first step, this part can be factored into a minus 5 squared, right? All right, so what's the top part? Top part, we just keep as it is. Of course, you can also try to factor them, but we don't necessarily do it. It's a current step. So right part, we combine them first, right? So a squared, actually, sorry, a plus 3, right? After combine. Okay, so we factor one of them off. Keep in mind, a cannot equal 5. We write down here. So we use the methods of crossing. Crossing here, only one left, so we can make it way much easier. So a minus 5, a plus 3, right? So actually, right part will do some further transform. 2a minus 15. Right? So we just skip them this step. Okay, so what do we find here? So a squared is all gone, right? So here combined together became negative 2a, and right part is became negative 3. So A equal 3/2. Right? Did you guys answer is the same to mine? Or different answers?
Same.
Same. Good. Okay, let's move on. Go number 11. So this one actually rational expression equation. You can consider it as a fraction, right? Just like A over B equals C over D. So use the kinds of proportion methods or just like crossing methods. Okay, let's see more complicated situation like this one. So first, we definitely combine since they have the same denominator. We combine them. So here, just combine together. So we right now, left is a fraction, right is not a fraction. So we can just both sides times n plus 3, right? So actually here, this one move here, n plus 3. That's way much easier, right? After do proper transform, we can way much easier. So here is became n squared plus 6n plus 6 for the left. Right part is n squared minus 9. Right? So n squared is gone. So we can get a 6n equal negative 15. N equals negative 5/2. Right? All right. So 3 steps. You can see first we do some basic transform. 3 steps, right? Progress way much easier. All right. See the number 12. Number 12. So first we make right part, make it a change, do proper change here. 4x. So here means times 2 here, right? So they have the same denominator. Okay, so will be changed into what? To be to x squared minus 7x. Here is minus 2, right? So it became plus 8. All right, so both sides times 4x. Both sides times 4x. Both sides times 4x. All right, so here became 2x. Right part is gone here, so it became x squared minus 7x plus 8. Or move to the right. Right, so we can factor them. Right, so you can get x1 equal 1, x2 equal 8. Have 2 solutions. All right, see number 13. Number 13 here. Number 13 here. First, we find same. We find the least common denominator. We find the least common denominator. Okay. So least common denominator would be k. So we do some proper factor here first. So this part actually we can say 5 plus, here is k times k plus 1, right? So least common denominator is k plus k. This is the LCD. So both sides time LCD first, right? All right. Okay. So both sides, let me change the color here. So both sides time k plus 1. So here right side is k. I just use this one right here directly. So k test 1, right? So you can see what's going on here. So left part equal k plus 1, right? K is gone. What about right part? So 5k times k plus 1. And the second part here, time here became 1. So you can see more simplified case, right? K plus 1 here is 5k squared plus 5k plus 1. 1 is gone. So let's see. So 5k squared plus 4k equals 0. So factor this 5k plus 4 times k equals 0. So k1 equals 0, k2 equals -4/5. Just as we see here, when LCD cannot equal 0, right? So k cannot equal 0, cannot equal -1. So we need to take this away, right? So only answer is this one. Okay, so LCD cannot equal 0. Just like any numbers, you cannot make the denominator become 0, right? Okay, let's move on. 14. All right, so first we move this one to the right part first. Move to the here. All right. So also do some proper transform. So here is p minus 6 minus p, right? P is gone, so it's -6/p. Right? So you can see, what do we see here? This is p minus 4 equal -6/p. Right? So p cannot equal 0, p cannot equal 4. We'll take this out first. And then we try to factor this p is gone, right? So here it became 1. All right, use the crossing. This crossing, so -6p minus 4 equal 1. So we do proper transform again. Equal 1, right? So 6p equal 23. P over equal 23/6. So they didn't conflict here. So this answer is be right here. Okay, let's move 15. If you have any questions, just don't hesitate to ask. All right. All right, let's see number 15. It's more complicated kinds of situation, right? Okay, so first we can see this part they have the same denominator, right? Move to the right part. Move this one to the right part first. Move this one to the right part. Became positive. Okay, so negative equal here. Positive plus here. So right part, we do proper transform one more time. N squared, take this out, n minus 2, right? So 6 actually is gone, right? So the top part here is n plus 5. So you can see here, n can be factored out one of them first, right? And this n is all gone as well. We know n it cannot equal 0. N cannot equal 2. Keep this in mind. All right, so we can use the crossing methods. Right? So it means 5n minus 2 equal n plus 5. So 5n minus 10 equal n plus 5. So you got a 4n equal 15. N equal 15/4. Okay, that's much easy, right? Just like try how you get rid of rational expression and transfer into general equation. All right, let's see number 16. The same, we can find they have the same denominator. We combine them first. So here it became minus, here it became equal negative here. Or you guys don't like to do this way, you can do like this one. All right, so x plus 2 is x minus x plus 1 equal -4. 4x plus 2, the bottom is x minus 3, right? So here x is gone. So here actually will be right, 3/3 here. And also we can factor this x out, but keep this in mind, x cannot equal 0, x cannot equal 3, right? So we'll do the combination, do the crossing methods. So negative 3x minus 3 equals 4x plus 2. Use crossing, right? With negative, we combine here, say negative 3x minus 3, and the rest is 1 times 4x plus 2, right? So you can quickly get it out of here. Right, so you can, right part is 7x, left part is 7. So x equal 1. X equal 1. Did you guys the same answer to mine or not? Yes? No?
Yeah, we got your answer.
Okay. Thanks, Thomas. All right. So rational expression actually right now is you can they have some two very complicated case, but you can just think about it. Let this kinds of progress actually just get rid of the rational expression, transfer normal equation, right? And then you can find answers. So we pass the rational expression part right now. We move to the radical part. Right, let's go to the radical part. Radical and root. So radical and root. Let's keep this in mind here. Let's go back to see radical. You guys maybe all know the prime numbers. So did you guys know where the radical 2 come from? Square root 2. What is the situation you can make it square root 2 in your real life? Did you ever met what number is square root 2? Ever thought about this one? I believe we talked about this one. Geometry, right? Right triangle, if one side is A, the other side is B, and the hypotenuse side is C. These three sides, they have the relationship is A squared plus B squared equals C squared. Keep this in your mind. This is very critical, right? I believe I proved this one for you guys. I said, let's use the C as to make a square, right? So this side is C, this side is C, this side is C. So we copy this triangle, rectangle here, goes to like this one. This is A, this is another right, and another one. You got a 4, 1, 4 rectangular. So the area of big one, you can see this part here is A, this side is B. Here is A, here is B. And here is A, here is B, right? Right? So this, you can see the big square, the surface area is C squared. What about inside part? Inside part is full of this triangle. Full of triangle. Each triangle area is what? A times B, right? Half A times B. And plus this small triangle, small square. What's this small square? Actually, this is A, this is B. So this is A, this is B. So B minus A. So here is B minus A and square, right? This is tiny square. The side will be B minus A and square. So we can find out that here is 2AB. What about this inside? B squared plus A squared minus 2AB. 2AB is gone. So left behind is C squared equal A squared plus B squared. Let's prove one of the methods to prove rectangular. This kinds of right angle triangular. One side is A, the other side is B. Let's see. They have this kinds of relationship. So when one of the side is 1, the other side is 1, what about C? C is square root 2, right? 1 square plus 1 square equal 2 equals C squared. So each side would be, the hypotenuse side would be square root 2. Square root 2 is not a whole number. This is not whole number, right? 1.414. This is called irrational number. Irrational number, right? Irrational number. they are not repeatable. This is not pattern repeatable. So irrational number. This is square root come from. So look at it. So you can see all the prime numbers. So you guys square root 2, square root 3, square root 4. 8. This one can transfer 2. 2 square equal 4, right? Square root 5, 6. 8. This 6 actually here is 2 times 3. You can rewrite it square root times square root 3. And square root 7, square root 8. 8 can be simplified. It's 2 times. So you can be transferred 2 times 4, right? And 4 square root 4 equal 2. Became 2 square root 2. So you can simplify it. I believe this one is already learned in the pre-algebra progress. And square root 9 here equals 3. Square root 10 and square root 11, square root 12, and here can transfer to 3 times 4. So it became 2 square root 3, right? And square root 13. So this kinds of square root, you can continue to work on something like square root 99, and this one can be transferred 9 times 10. So you can square root 9 times square root 10. So here equals 3, right? You guys know this one already, right? Learned this already before in the pre-algebra part. So right now we transfer into square root, actually is x. Square root x. So you can see inside it, just one layer is square root. The inside this x should be greater or equal than 0. We didn't learn negative. We didn't learn this part yet. We would have talked about, maybe if time allowed, we would have talked about this one if they are negative. But we disregard negative up to now, okay? So all the square root inside here, underneath here, radicand, we call radicand here, should be greater or equal than 0. Should be positive number. They have a square root. They are negative number up to now. They don't have a square root. Okay, so have a square root. So this the property is the same like this one, all right? Like this one. You can simplify it. And you can see square root a and b. If both a and b is a positive number, they can transfer into like this. If they are a over b, if a and b both are a positive number, they can transfer like this, right? They can both way. They can go this way and go that way as well. But what about addition? What about addition? A plus square root a. So here you can say 2 of them, right? This is like terms. This is like terms. Just like you have 2 square root 2 plus 3 square root 2. This is the number like 1.14 or something. And there's 2 times of this number and 3 times of this number. So you can also combine like this. Right? So you can 2 square root x plus, plus 3 square root x so you can also the same, they can combine here like square root x. Suppose x is greater equal to 0. Okay, let's use some homework to see what's going on here. Right? So very similarity to you earlier learned square root and the radicals. The only thing is some of them we introduce some were writable right now. Okay, so see this one, just like we're saying here, this one actually you can simplify, this one is 25 times 5n, right? So this one actually you can break it down 25 times 5n. So here is 5, right? So you can 5 square root 5n, right? 216. 216, what square equals 216? 36 times 6, right? 36 times 6. So you can say 36 times 6v. So here 36 can break it down and then change into, right? 512. 512. You can see what 269. I'm sorry. 512 actually is equals what? Did you guys know that? What's the number can be broken down into? 516, you can break it down 256 times 2, right? K squared. So 256 K squared times 2, right? So this one actually 16K, right? 16K times square root 2. So here is breaking down into similar to this one. So it's 256 m squared times 2m. So here became 16m and square root. This is time dot. You get 2m, right? Just similar like what we earlier learning is a, b. Actually, this can be changed into like this. Suppose a greater than b greater than 0, right? And each of them, they can simplify it. Okay, let's do a little bit further. All right, see number 5. So here is 36k square root times 6. So you became 6k squared times square root 6. Right? Here is super easy one for. So here 100 v squared take off the, when they take it out after square root, you became 10v times v, right? So 16p squared times 5p, right? So here can breaking down became 4p square root 5p. What about this one? 9p squared times 5, right? So you can get a 3p. What about this one? So this one, 147. 147 actually here is 49 times 3, right? So m squared, n squared, and m, we put a 3 here, right? So like this. So you can get here is 7mn square root 3mn, right? This one. So this one is 100m times 2n. So this one can break it down by itself, right? So you get 10m squared square root 2n. That's way much easier, right? Okay. Just check a little bit more. Some like this one. This one, just like we say, we can break it down, factor it, actually factor it. Factor it is 25x squared and rest is 3y, right? So you can get 5x times square root 3y. Like this one. So here is 64m squared, n squared, and rest is mn square root of them. So this part actually can break it down, it becomes a mn, right? And the square time, here is time, square root mn. So I just need to directly write the answers for you first. All right? So you guys can do this one, all right? So 28, you can break it down 4x squared y squared times 7xy. We try to make this one is something square, right? After square root, it became 2xy square root 7xy, right? So very much easy. All right. Keep moving. If you have different answers, please mark it on your answers. Just mark it and then do one more time. All right. So like this one. So this one I can write direct answers, right? You guys can write direct answer out of here. 6xy square root of y, right? Same. 3a4. What square? What is 3a4 can break it down into what? We can break it down at least times 4 time what? 96, right? 496. So 96 can continue breaking down. So 4 times 16 times 6, right? Okay, so here actually you can of course you can rewrite it one more time here. All right, so for here actually is 64, right? 64 times 6, 64. So we put a 6 here. We bring the 6 to the right here. So here it became 64, became 8. 8x squared y, and the rest is 6y, right? So we take this out. So need a little bit, make sure you do some transfer. This one is something square, all right? Sounds good? All right, so see 17, let's see 17. With 96, we got 16 times 6, right? So 7, we just copy this one. This is 16 m squared times 6m. Right here, 96 m cubic. So here take is 4m times 7. So became 28m square root 6m. What about this part? This part is 6. 72. 72 can break it down 9 times 8, or maybe different. 36 times 2. Right? So here became 6x. 6x, take it out, became 36x square root 2. Very much easy, right, everyone? So here, let it go. Looks like no challenge for you guys, right? That's so easy. What are we teaching? We teach all very easy one, right? Okay, so see this one. So negative 6. Here again, 25 times 6 r, right? So you can get here is negative 30. Here, take it out, 5 times 6, 30. Square root 6r. What about this one? 5. Here is square root 16 a squared times 5, right? So it became 4a. 4a take it out. 4a times 5 got 20a square root 5. Right? Okay. All right. Let's move on 21. Let's move on 21. 21. So here equals 2 times 25 times 5, right? Times 5v. 5v. Okay, it's easy. So here you get 5. 5 take out 10 square root 5v. Right? So simplify case here, actually, you try to factor anything inside, make sure it became something square. Okay, let's see this part. Negative 8. Here it became what? 4 times 6, right? So 4k squared. So 6k. So we put this part just like something square, like something square. So the rest. So it became 2k. So 2k times negative 8, it became negative 16k square root 6k here. Right. So what is similarity here? Right? We just need more practice here. So here, 192 can break it down into what? Breaking it down. Did you guys? 64 times 3, right? X, right? So we need to do these kinds of progress. So here became 8, right? 8 negative 4 times 8, 32 square root 3x. So this part Let's see 24 here. 2 square root. Here became 4p squared q squared times 2qr. Right? We just factor this one. So make this part is became something square. So here it became 4pq. 4pq times 2 became 4pq. So the rest is 2qr here. Oh, all right. So we're almost end here. Let's see the -4 here. 25 here. So -4 here. So we know this one is 36 times 6, right? So 6x squared y squared times z, 60. So here it became 6xy. Became 24xy, right? All right, so the rest is 6z. All right, so let's do a little bit further for the 26. So here 4a power 4b squared c squared times 6c, right? So we take the rest, only c left here. So here this part we can became 2 times -6 a squared b c square root 6c. 6c. Right? Anyone have the same answer or not answer to mine? All right, we have 4 left. We will talk a little bit quicker. All right. If you clear, let's be great. If you have questions, don't forget to answer. Don't ask. Let's see now 27. 27. So the same. So all this progress is the same, right? So here is try to become 16x power 4, y power 4, and only z. So only z left. So here it became 4. 4, take it out, it became 4. 4 times 3 became 12. X squared, y squared, and square root z, right? Because of this part, it became 4x squared, y squared, square. Right, do a little bit further here for this part. Here it became 16. So 48 will break 16 times 3, all right? So here is a squared, left a here, b power 4, and c squared. So this part we can take it out from the under the square. So here it became, here is 4, 2 times 4 became -8. A, b squared, c, right? And left inside is 3a. Okay, so same here. Here is 25 and left times 3. M will take here p squared q squared and left 1q here. So the left part we can square root this one, right? So we can 5. 30 pq square root 3mq. All right. See last one. 4. We know the 36 is became 6 squared, right? X squared, y squared, and additional y here, z power 4. Okay, so here is 9. 4 times 9, still go back 36. I'm sorry. Here's 6. 4 times 6 is 24, right? So x, y, z square root y. All right. So we take some time to practice, just like say how to simplify the square root and make sure the square part can take it out of the under the square. Right? Okay. So our homework part review is done. So we move on the new topics. Do you guys still need to take a break? If not break, we just need to move on our topics right away. Okay. All right, so let's move on here. Because time a little bit short, I just move on this part quickly, all right? So we finished the homework review. Let's go to the new topics.